Assalamu alaikum students, your teacher Omar here. Today we are going to study electronic configuration of atom and Hund's rule, Pauli's exclusion principle, the Aufbau principle, which is also known as Keleschkovsky's principle in Afghan Marif books. Okay, let's start with the question again. What do you know about the arrangements of electron in quantum numbers? You have studied in previous lessons that there were two electrons in the first principal quantum number and 8 electron in the second one and the 18 electron third one, 32 electron in the fourth principal quantum number. Okay, so how can we arrange these number of electron in these principal quantum numbers, subshell orbitals and their spin? Okay, so this is our question. Let's solve this question. A detailed way of writing electronic configuration of an atom that includes information about the number of electrons in each subshell is known as electronic configuration. Okay, so electrons are arranged in the shells around the nucleus. The first principal quantum number, which is closest to the nucleus, has the lowest energy, which means that electron will sit in the first principal quantum number first of all, then it will go to the next one, then next one, and so on. So each shell can only hold a certain number of electrons. Okay, how to find how many electrons and in which subshell and in which orbital they are sitting or they are arranged? There's a principle which is known as Aufbau principle. It states that electrons are filled in atomic orbitals in increasing order of orbital energy level. For example, we know that there are 7 electrons in nitrogen, so its electronic configuration will be 1s2, 2s2, and 2p3. I will show you how can we write how many electrons are coming in each orbital, but before that let me show what does it mean. What's the meaning of 1s2 or 2s2 or 2p3? Let me show you. You can see over here, if you remember from our previous lesson, n was a symbol of principal quantum number, and we remember that the value of n starts from the 1. So you can see 1 is the principal quantum number. It designates the first principal quantum number, and the s was for the subshell. So in first principal quantum number, the secondary quantum number is s, and we know that s has only one orbital, and you remember each orbital can have only 2 electrons. So this shows the number of electrons in the orbital. So how to find which orbital have the lowest energy? We can use n plus l rule to find electronic configuration with the help of Aufbau principle. Okay, let's have a look.
Well, students, as we have studied what's Aufbau principle, let's use Aufbau principle to find out electronic configuration of an atom. Let me show you n plus l rule. How can we use this n plus n rule, or how does it work? Okay. The relative energies of orbitals can be predicted by sum of n plus l for each orbitals according to the following rules. N is the principal quantum number and l is the subshell or secondary quantum number. You remember from the previous lessons. There are two things. Orbitals are filled in order of increasing n plus l. In order of increasing n plus l, which represents the relative energy. If two orbitals have the same value of n plus l, in this case we use the order of increasing n. We will see which principal quantum number comes first, then we will fill the orbital according to that one. Let's work on an example. Okay, students, over here I have written n plus l, which shows the relative energy value. You remember from the previous lessons, 1 was the first value of n, the principal quantum number. N is 1 over here. And for L, you remember it started from the SPD. There were 4 secondary quantum number or subshell SPDF. The value of S was what? 0. The value of N was 1. So N plus N for the 1S is equal to 1. Okay, this is the relative energy. Let me continue until the last. For 2s, 2 for the n, and for s, we know what's the value of 0. So 2 plus 0 is 0. What about the 2p? For 2p, 2 for n, 2, and for p, 1. You remember from previous lesson, the value of p was 1. 2 plus 1 is equal to 3. And for 3s, 3 plus 0 is equal to 3. For 3p, 3 plus 1 is equal to 4, because the value of p is 4 and the value of n is 3. For 3, the value of d was 2, so 3 plus 2 is equal to 5. For 4s, 4 plus 0 is equal to 4. You remember the value of p is 1, so 4 plus 1 is 5. So there's a question, how can we fill the orbitals according to this n plus l rule? Let's work upon the example of sodium. Sodium has the atomic mass of 23 and atomic number of 11. If you write for the sodium, we can write 1s2. How many electrons? 2 electrons. 2s2. We finished this one, and then what? 2p. How many electrons were in the p? 6. Why we use 2p before the 3s? Because when they have the same value, I told you that we will look at the value of n. So over here 2 is smaller than 3, so that's why they have same relative energy value, but we will bring 2p first. So 2p 6. How many electrons did the sodium have? 11, because that number of electrons are equal to the number of protons, or the atomic number in a neutral atom. So 1s2, 2s2, 2p 6. How many electrons? 2 plus 2, 4, 4 plus 6, 10. Now it needs 1 electron. Which one of them has a turn? 3s. So we can write 3s1. This is the electronic configuration of sodium. Let's work upon the bromium. This is the electronic configuration of Br, or the bromium. Okay, let's study the next rule. What was the next? Is Hund's rule. Hund's rule says that every orbital in a sublevel is singly occupied before any orbital is doubly occupied. You can see over here. This is for the carbon. The 1s has 2 electrons. The first electron comes, then the next. Then we go for the 2s. The first electron comes, then the next, and for the 2p. We cannot write both electrons in the same orbital. If there is an empty orbital, it will be singly occupied, and then it will be doubly occupied. That's what the Hund told us. Let's have a look at the next rule. The next one is the Pauli's exclusion principle. It says that an atom or molecule cannot have same it says that no 2 electrons can have same 4 electronic quantum number in an atom or a molecule. For example, we know that every orbital can consist only maximum 2 electrons, so they must have in the opposing spin. You can see over here, this was the correct. If we write like this, in this case, this electron and this electron, both of them have same spin. So according to Pauli's exclusion principle, this is wrong. So they must have opposite spin in each orbital. So in one atom, none of the 2 electrons can have same 4 quantum number. This is what the Pauli's exclusion principle. Okay, students, so over here I will show you how can we fill up the orbitals of the subshell with the electrons. We know that there are 4 subshells, S, P, D, F. Okay, so I have written over here. How do we write this? First of all, we write 2S, S 2 times, then PS 2 times, DPS 2 times, and FDPS 2 times. But we don't write S at the last because it falls in the 8th principal shell. So we don't have 8 shells. That's why we don't write the S at the last. So we know that the subshell S starts from the first principal shell, principal quantum number, P starts from the second, D starts from the third, and F starts from the fourth. So I have written the values of principal quantum numbers with, beside the orbitals. So when it's first, it means that it will be second, it will be third, it will be fourth, it will be fifth, sixth, and seventh. Okay, so what about the P? P starts from the second. So over here, P is third, fourth, fifth, sixth, and seventh. Exactly. So these start from the third principal quantum shell. So 3, and over here is 4. It is 5, and it is 6 over here. You remember the F started from the 4th principal quantum number. We have only 2 Fs. This is 4 and this is 5th. So with the help of this electronic configuration, you can write the electronic configuration of any element, as I've worked 2 examples before.
Thank you, students, for watching today's lesson. I hope you have learned something new. If you have any questions, you can write in the comment section below. And please don't forget to subscribe our channel and give a thumbs up to our videos. Goodbye.